Welcome to lecture 20 of Financial Mathematics for Actuaries. Today, in the problem solving lab, we are going to discuss about retirement planning, which is the dream of everyone who is planning their financial goals. So, let us understand this retirement planning from the perspective of annuities. So, assume that a person is retiring at the age of 65. He wants to start investing from the age of 25, and he expects, based on life expectancy, that that person will live for till he is 90-year old. Okay, so this is the basic understanding. So what he is planning is he plans to save till he goes for retirement. Okay, so this is the initial accumulation stage where we are accumulating money, and at till we when how long will we accumulate? We will accumulate till we reach 65. Okay, one more important point that we need to understand is, this is okay that we are accumulating till 65, but how we need to understand what will be our need after 65 and till 90. That means for next 25 years what will be our need, and in that period after we retire we need to take that money at a certain speed, correct. So this is 25 years and I need to take that money. So the main question is, what is that ideal number which is given by this yellow dot or golden dot that I should reach when I am retiring. Okay, so that's the question. So the calculation will start backward, that is I will look at this particular curve first or this particular line first, then I will come back to this dot, that is the tower, and then I will calculate for how much I need to save from the year 25 of my age. So this is the basic understanding. Okay, so let us go with this second graph where we are distributing the money, and for this distribution what do I need to worry about? What should be the present value? That is, so in this case the present value denotes the focal time point, which is at the age of 65 when you are retiring, right. So these are the premises under which we have to operate. Okay, so let us list the premises first and then we will calculate. So the first comes is our liabilities. These are the liabilities that are visible here. I will retire at the age of 65, live until 90. I need $5,000 per month at the beginning of each month. Remember, this is important. I want the money upfront, first of every month I need that money, and I may not be very aggressive in investing the money. I may not be interested in investing in risky assets. So what I will do, I will take assets like small investments which are less risky, like bonds and all. So the interest rate while I am retiring will be only 4% effective interest rate. That's what we are assuming, which typically bonds will give. Then what we are looking at, then the question is, when I will retire, what should be the lump sum amount that I need at the age of 65 if I come backwards for 25 years. Okay. So as we have done in the last class, we need to take these monthly payments and calculate what is one golden unit that we have to calculate, which is 12 times 5,000, 60,000, and then I will look at the annuity due, because I need the amount to be paid at the first of each month. That is why this annuity due is required and compounded monthly. So the bracketed number is 12 for 25 years. Okay. So with this we are ready to launch our calculator drill. So we will simply use our calculator to solve this problem. Okay. However, in calculator you don't have to worry about this annual payment. because you are only entering the PMT values, which are payments monthly. So, because it is annuity due, for calculator what you will do is you will start with BGN mode. So, as usual, set the calculator in BGN mode, which is critical. Then you set payments per year equal to 12, set cash flows per year equal to 12. Then, because there are 12 payments in a year, you have to multiply by 25 to this 12, and there will be total of 300 payments that are there. Okay. Interest rate per year is going to be 4%, and then how much money you are going to put in? PMT will be 5,000, and what will be the future value of that money when you reach 90? The value should become 0, right? Now you are set for the computation. So you just compute the present value. The answer should come out to be 9,50,419.96, that is 950,420. This is the amount that you are looking for when you retire at the age of 65. Okay. So, this is the height that we want to build a mountain of. So, now the step 2 begins. So, this is we got the number that you see that golden dot, that number we have already received now. Now, we have to calculate backwards. This should be the future value of whatever investment we are going to do. So, how will you do that? The asset building stage starts. How much to save? My current age is 25. I have time span of 40 years till I reach 65, and I am working, so I can invest in high risk assets. So, interest rate that I may get during work time is 8%. And my goal that we have set is 9,50,420. So, the question now that we are posing is, how much shall I save monthly at end of each month? So, that is how much payment I will do monthly multiplied by 12, that much I am saving annually, multiplied by the future value of 40 years, that is S angle 40, when compounded on monthly basis 12. Okay. And I know the answer to be equal to 9,50,420. How will I compute this? We already know the steps, right? So, again go to your calculator. You are in BGN mode. So, switch to end mode. That's very important. So, once your calculator is set in end mode, again check whether payment per year P by Y is 12 and C by Y is 12. Then what are the number of periods for which you have to pay? N, which is 40 years into 12 years into 12 months, which will give you 480 months. Okay. And then over that period, interest rate, effective annual interest rate is 8%. The present value is 0, and the future value you want is 9,50,420. So, then you have what you have to compute? You have to compute the PMT, payment that is due on a monthly basis. So, it turns out that this PMT is $272.25. So, basically, if you want to save close to $1 million, you need to only pay $272 per month if you start at 25. This raises an interesting question. Suppose I wait until the age of 40 or 45, let us say. Okay. How much do I need to pay if I wait till the, so in this case the target is still the same, 9,50,420. We have not changed. What we have changed is the number of months. Instead of saving for 40 years, we are saying we want to save only for 20 years. Okay. So, N is equal to 240. So, in your calculator, you do not have to do much. You just go and change that value of N, set that N to be equal to 240, and again compute PMT. You will get the answer $1613.56. So if you compare, if you start your savings at the age of 25, you just need to save $272, and if you start your saving at the age of 45, you are essentially saving 6 times the amount that you started saving at the age of 25, right. So that means waiting for 20 years may increase your burden by 6x, or starting early 25 years or 20 years will reduce your burden by 6 times. The saving early is a better choice, right. So this is the basic calculation of retirement plan. So what we have done is we have essentially created one equation of value which is called unified equation of values. We looked at our focal date, which is our retirement age, and on the right of that we looked at our needs, and we understood some payment to be needed for satisfying those needs, and we calculated present value of needs. Then we actually came to a amount which was required, and which we equated with our accumulated savings, correct, and then we actually estimated how much should we save. So all these things are essentially translating into one nice formula which we call as unified equation of value, where we started with 12 monthly payments that you need to save and multiplied it with the annuity, future value of annuity at work, which was higher interest rate, and then we equated it with, you take that amount, you put it in some low interest rate fund, and how much payment you will get, and that is what this A double dot retire will show, which is the annuity due every first of the month. You will get that money, so that your future is safe. Here that S work and S retire have both different interest rates. I have already made it clear. So work phase, you have a capacity to earn more money, so you will invest in high risk, high return portfolios. In the retire phase, you may choose to have a less risk and less fluctuation, volatile portfolio. That is why you expect lesser interest rate. So with these calculations, we are set for retirement planning, right. So now let us take another scenario where a person says, I only want to work for 20 years and then retire. I can save as much as I want. So I can save up to say $2,000 per month. The interest rate that I will earn is 7%. And at the retirement, I want 4,000 per month, and for 30 years I want this amount to be coming to me, and the interest rate may be 5% at that time. So now you are willing to evaluate this scenario, and you want to calculate how much money this person will have, how much money this person will withdraw, and when you are actually at year 20, will you be in surplus or in the shortfall, right. So with the given methodology, remember here there is no beginning of the period, both are end. So you do not have to get into BGN mode, you can work with end mode provided you have resetted your calculator. Okay, so pause the video, check the answer and come back. Okay, welcome back. So let us look at the solution. So first, very clear, we have t is equal to 20 at which is our focal date, and we have to analyze the scenario. So P by Y, payments per year are 12. What since 20 years, so the N is 240, I by Y is going to be 7%, and the monthly capital that we are investing, so PMT is 200, present value I have nothing, so it is 0, your mode is end mode. Compute FV. So that will give you this number, which is roughly 10,41,853. Okay, this is the future value of your amount. Okay, now the other thing comes. So this is asset building. Now comes the liabilities. What are my needs? So I said, we mentioned that I need $4,000 per month, right? So so we will push in all those values. So at t is equal to 20, we have payments per year 12, PMT is 400. I want the payment to be done for 360 months, that is 30 years, and the interest rate is 5%. Okay, with all that you are set. You just take compute, and what you will compute is the present value, and with the present value you got 7,45,126. Okay, so if that is the case, that means what you had, you roughly had $1.4 million earlier, and from that you are actually withdrawing 126.47 So roughly, if you take the difference, you are in the safe zone. You are having a surplus of 2,96,000 and some amount, which is good. So you are actually satisfying your needs. So now we have done this all these things, but what in all these problems we had one assumption, that whatever the amount 4,000 or 5,000 is buying at this time period or in the present, I will have a same buying capacity, right? But you know the silent killer, inflation, where we know that the 5,000 rupees today cannot buy same thing after 40 years. Okay, they will buy significantly lesser amount of goods. Therefore, we need to look at certain concepts like geometric annuity, where the payment will grow by G% annually, and we have already triggered this in our week 2. The inflation rate causes the real interest rate to decrease. So we will bring that factor in and calculate the real interest rate I prime, where R is the inflation factor and I is our effective interest rate. So we will bring these factors and we will use them in an effective manner to calculate level annuities. So let us we have done enough. Now let us review what we have done in this week. For formulas, you just need to remember these important formulae. Other than that, most of the things will be done by the calculator. So annuity immediate is A angle n, which is equal to 1 minus V raised to n by I. So if I put double dot on it, what will change? It's the you remember our denominator slice machine. It will be replaced with D, but you don't have to memorize this. The denominator will be replaced with D. You don't have to memorize this because everything is multiplied with 1 plus I. If there are n periods, 1 plus I raised to. Okay. So Sn is the future value, which is again very simple. It is n time steps forward. So multiply the present value of annuity with 1 plus I raised to n, you get the answer, correct? If it, all these are immediate. If you want to look at annuity due, multiply by 1 time period, 1 plus I. When you have monthly annuities, you look at the denominator. If it is immediate, the denominator is IM. If it is due, the denominator is DM. Okay. The traps while using calculator are BGN and end mode. You have to be careful about it. Payments per year always reset to 1 and the valuation date. So, if you remember all these things, you will have a very easy going calculations for entire question bank. Okay. So, what is coming in the next week? We are saying we are leveling our game. We will look at level annuities, right. So, for that we need two concepts. One is perpetuities, another one is continuous annuities. Perpetuities are nothing but, if I do not want to stop the payments, I want to continue, let the payments continue till n is infinite. So, that is perpetuity. What if I reduce this compounding frequencies and payments will flow continuously like water? So, all these cases we will discuss in the next week. See you in the next week. Thank you.